How about now? Hey, welcome to Coffee Compiler Club. Hopefully here today to talk about compilers and language runtimes and typing systems and things like that. I'm fighting with an AI in the background who's been entertaining. The AIs have gone from, oh, that's a cute toy, to really, you can do that, to hey, quit bugging me and get this thing done. And it's all pretty quick from that's a cute toy to wow, this is a useful tool. Um, and he's been trained on Gradle and enterprise level coding by the billion lines worth of it. So he's pretty good at that kind of stuff. And I like don't know, don't care. And protobuf schemas and things like that. And I'm again like, this means nothing to anything I'm doing. I don't care. Do what it needs to be done, and he does it. So okay, well, it's been an entertaining good time.
Yeah, I
All
found
right.
the AI is just super useful. I've been using it to implement my LLVM backend. It requires supervision because it makes a lot of mistakes, but
But the mistakes it makes are higher level, if that makes sense. It's gone from
yeah,
making mistakes like he can't spell his name or he thinks the sky is falling to mistakes like, did you want me to delete this entire order book implementation and all its corresponding friends or re-put back some butchered version of it that I deleted a while ago or something? I'm doing architectural changes and he's pointing out the pieces that haven't been thought through yet. It's totally reasonable. And I have to figure out how I'm going to get him to quit asking me whether or not he can run various flavored versions of grep and Gradle run test and awk and sed and things. Like if you don't
you could turn
leave the working directory, the project root directory, if you don't leave the project root directory, I don't fucking care. Quit bugging me. And I keep telling him that. And yes, and don't ask me again. And he asked me again.
well, the app is coded to require permission to go outside the sandbox
Oh, I
usually.
totally get it. And I totally know why. And it's just like, we got to work on that one next. To get this tool into this next level of usefulness, I need to have some better, easier set defaults, which
I
probably is
I
up
I
there and everyone knows how to do it. And I just haven't figured it yet.
well, I think with Gradle, it's probably there's some cache directory on like home.gradle, and it's like, oh, I can't access that because that's not inside my
Right,
sandbox. So
right.
what you do is you tell it like just redirect everything into temp. So like, okay, if you need access, don't use the cache of the system, just create one in temp. And then it'll also do it if it needs web access. So that's the other thing. So this is like if
Oh,
it needs internet access. And then
that's
Gradle's
tricky.
like, I
Oh,
want to download stuff. So Gradle is in particular really bad for it.
here's
What I've been
bad.
looking, what I've been looking is basically sandboxing the agent itself with tools like Agent Shell. You can also use a micro VM and then run it with all permissions. But you have to set up the policy. So this tool that you're using like now, just looking at now right now, Agent Shell, you can set policies like access this GitHub the website. If you have your own GitHub instance, do only reading from this, use only this command with those parameters, yada yada yada. And basically, when you do have a security sandboxing policy like that, then the agent harness itself can run in the allow dangerous permissions or YOLO mode, and then it's not gonna bother you. But you have to spend some time on setting the policies. And you do need a proper sandboxing. I think micro VMs today are a better idea than some people were using containers, and containers are not the right tool for the job because they're really just namespace C group based permission partitioning system. So
Right.
I would look into micro VMs.
All right. Yeah. I'm in the zone here where I need to up level my permission strategy. So yeah. All right. I'm going to set this aside and ponder it deeply later because that's going to take a bunch of work to make that work. On the other hand, I'm actually really enjoying the AI to handle all the random Gradle crap.
I am actually curious what others are doing because a lot of people have different ideas.
You see others like not me or others like just in
Yeah,
general across.
anyone who's also like doing sandboxing plus the policy plus the YOLO combination.
I found a bug in my that I had, well, I don't know if it's a bug, but I was using the AI, and every time I would have the AI build my project, right, it would do a full rebuild if I had built it normally. And it turns out that the sandbox was blocking a call to a sysctl that lets it determine what the architecture is. So CMake would just fall back to like default, and then this would cause like a tiny change on the command line to Clang that would change the architecture. But that would cause Ninja to do a full rebuild because it's like, okay, well, the command line's different. And so I had to like create a workaround in my build tool that was like, okay, I you have to pass this in like command line option on to like manually set the architecture because it's not going to detect it inside the sandbox. And now it doesn't rebuild every time. It switches between the sandbox and regular.
Yeah, I had similar issues. I ended up creating a custom agent for building LLVM-based compiler, exactly so it does it right, and it also does it on the side.
Well, I'm just using my C build, which
Hmm.
is working very well actually. So I just type C build and then it builds LLVM if you've changed it, and then it builds my compiler and then it links it. So
Like I
I
might have
have
to get this sorted out for the simple project too. There's like an obviously I need to use AI on the simple project to finish up this last chapter here. And then just to clean things up, there's a lot of in chapters 22 and 25, there's a lot of ooky stuff that I just threw together to make it work, and it worked, and it's ooky.
By the way, I recommend running adversarial code review with multiple models. Like if you have
Uh,
one model like Plot Opus that does implementation, then run adversarial review with GPT. And adversarial means that there's even plugins for that, that you want to find the strongest reason to reject the patch. And you want it to look for mistakes and you want it to be skeptical, assume this is a bad code, please look for the reasons to reject this code. And I actually had some success with that, especially if you have one model review the other.
so this is
yeah.
Aaron pointing out how much time should I spend making my AI agent stop asking me inane questions in order to get
Yeah.
forward progress?
If you for some very simple things you can use hooks. Most coding agents have hooks, which is basically a shell command that runs each time agent is about to do something. Like if it's about to ask you for the tool use, there is a hook called pre-tool use, and you can filter this. Like if it's just reading these files in these directories, automatically approve. Those are relatively easy to make, and because they are automatic and because they are shell scripts, they are also deterministic. Some people even do things like after you edit CPP file like Clang format, but I'm actually of two minds about that because not everything has to be formatted. Like if I'm reducing a patch, I'm not going to be committing this C++ code anywhere, so it doesn't need to be formatted. But there's a lot you can do with agent hooks. Whichever harness you are using probably supports something like that.
I'm sure it does. This is like top tier Claude code.
Yeah, if it's cloud code, then it actually has a lot of hooks.
Yeah.
And that's useful for automating some of the tedium.
I'm kind of in the zone of do anything you want in the project directory and do anything you want making modifications to Git as long as nothing gets pushed off my machine. If it's sitting on my machine, I can always unwind and throw it away or try again. And he asks endlessly, so yeah, it's time to get a something sorted out. He quits asking me.
That time I also recommend like creating custom agents for like long running tasks, especially if you want to do it in the background. Like I had one for monitoring the GPUs. Like if I run the test that can break something on the GPU, it's actually a pretty long process to test on the GPUs because the machine has to be managed. No one else should be running tests on those GPUs, yada yada. They sometimes get stalled because GPUs can be finicky. So you can have agent monitor the compiler test running on the GPUs, check up on them from time to time, restarting the test if something gets stalled. It's actually useful for that kind of tedium. I also have another that basically reads the PDFs from this compiler correctness literature I have since 1960s and incorporates some of the common compiler bugs in the adversarial review agent. And I actually did find some of the bugs in LLVM. I like my patches that way, so it's kind of working out for me.
Okay. All right.
It,
All right.
Definitely have to review every single line of code myself. Still, I don't believe in vibe coding. I think I believe in the opposite of vibe coding, but I'm still finding it useful.
Okay. Okay.
So, Cliff, I'm curious what your thoughts are on going back and changing earlier chapters versus having cleanup chapters.
Oh,
Because I've
once I get
had
the AI
some
involved,
professors who
they'll be
swear by just code things in the front of the room in front of the class so they understand that software gets written terribly and then gets cleaned. And
ah
there's some people who are like, no, I want them to instinctively reach for clean architectures. I should only show them clean architectures so they don't develop
don't
instincts.
develop bad habits. Yeah. Okay. Um, I have intentionally left a handful of bugs in some earlier chapters that are fixed in later as a demonstration of, hey, this is an issue. I have some big architectural changes that are difficult to understand without me really diving in deep as to why I made this change, which may be the more important learning to be had there. Um, and then there's a bunch of changes that are sweeping, broad, and only for bookkeeping purposes. So, yeah, I think if I pull agents out and have them start doing things, I think the a bunch of things will happen. I'll try to get the chapters a little more uniform size and the concepts from chapter to chapter a little more easily bitten. When I see an architectural change has to happen, that there's this theory that says in the first few chapters the design is super simple. And it just doesn't have the things that are going to be required in the end for the fully functional compiler. So,
Yeah,
and I
and
don't
it's
want them
worth
there because
leaving
it
out
makes
stuff,
it.
even though you know you're going to need it later.
Yeah, I'm leaving some stuff out, even though I know I'm going to leave it later in order to make life simpler. So then I want to have a nice discussion that says, we took this shortcut. I didn't even want to tell you that it was a shortcut in chapter one because it wouldn't make any sense to you. But here we are in chapter eight, and oh, look, we can't deal with X, Y, and Z, which has to happen. So now I need this change. It's like chapter one doesn't mention types at all. Chapter one is literally return a number as your compiler. Write a program that reads a piece of text, parses the return word and a number. So no types. Types show up in like chapter four as integer types. Somewhere around chapter eight, I pick up control, and then by 10, I have control and structs and pointers, and then it gets crazier and crazier. So the architecture change is I didn't deal with types to I did deal with types. And then the types are super trivial. Then the types kept getting restructured. So the integer type is basically, the beginning one is basically a flag saying I'm top or bottom, or I'm the constant, and it's this classic integer constants for constant propagation.
You are capturing some of the backtracking that has happened.
Yeah.
That
And
was one of the
so I
things that used
would,
to annoy me about. I had a bunch of math people that I worked with, and they would show up with their proof, but their proof is a linked list, and their proving process is a tree. Except every time they went down a dead end, they just didn't include that in the thing they showed you.
right. Okay.
And you look at it
So
and it's like, and now I'm going to add this funny zero that's this complicated thing minus that complicated thing. But you can prove those two complicated things are equal. So I added zero. Okay, now I go to my next step. And you're like, what just happened here?
right.
Why did you do that? And it's like, oh, well, there was all this exploration on different branches of the tree that you didn't see. It
Yeah.
was actually not necessary for the proof, but was totally necessary to get to the proof.
That's a piece that I want to approach carefully. It's I made a bunch of mistakes. Okay, I did. I cleaned them up. Okay, you got the cleaned up version. The exploration tree was interesting. Um,
Right.
how
I
much
don't
of
have
that do
an
I
answer for
include?
how to teach students to do exploration trees other than just like assigning them a lot of homework.
Yeah, right. Yeah, and you have to go code this yourself. And then nowadays, the fucking AI comes along, and then you can't teach them to code because they'll just ask the AI.
Yeah, if the exploration tree happened in the thought process of an AI and it didn't spit out the thought process.
Uh-huh. And maybe you're now moving, and maybe that's the right answer is you're moving to a different zone. It's you're doing architectural exploration. Um, and you make mistakes in your architecture and you rethink it. And the AI is kind of bad at architectural design. It just is. But the problem for me with an AI and architectural design and somebody else is how are they going to learn architecture if they don't understand the thing they're building over? And maybe that's okay. You talk about a building architect. They take a whole lot of civil engineering classes to understand how buildings hold up before they're allowed to go design the structure,
Yes.
shape, look, how people use a building. They
When you're
have
doing building
okay.
architects, it is always obvious which is heavier, a nail or a floor of your building.
Wait, I missed the analogy there.
In the computer software systems, I often see people that are grabbing little snippets of code. I mean, I saw this from Stack Overflow and stuff. And it's like you're in the middle of your hot loop where you're doing a bunch of things that take nanoseconds. Do you realize the thing you just inserted takes a millisecond
Right,
and is
right. Okay.
literally a million times heavier than everything else in your inner loop?
Yes.
And that's not always obvious.
No, apparently not. That was my first 3 months at this company was, look at this stuff you guys are doing. This is
You're just
amazing.
like,
This is
I
crazy.
I
why did
have
you
a
attach the floor of the building to your nail? That's going to make
Yeah,
it hard to
okay.
drive the
Yeah.
nail in.
I have a story related to that. I this so sometimes, two to the n algorithms can be very fast as long as n is small.
As long as it is small.
So I couldn't figure
Enough.
out why I was spending so much time when I was doing map lookups. I was like, why is this so like why am I spending all my time in these red black trees? Like, oh my gosh, this is like all my program time, right? And I figured out eventually that there was a bug in the way that my comparison like overload worked. So there's something in C++ called a three-way comparison.
Yeah.
And I had implemented what was supposed to be a fallback implementation for types that didn't have the three-way comparison, but I forgot to make it a fallback. So what it would do is it would check less than, and then it would check greater than, and then it would know which of the three, like, is it less, equal, or greater that it is. But what if that kept happening at each level up?
Yeah. Yeah.
So it would do
You
two
go exponential.
comparisons. Yeah. And so anyway, I accidentally forgot to add the this is supposed to be the fallback because like at some point I had stopped using that function as like the fallback and then I just started
Yeah.
using it everywhere and I forgot that it did this. And then anyway, all my comparisons went exponential and this went on for a long time because
Because
the
n was
depth of the
small.
types wasn't big enough for me to notice. And then all of a sudden, when I got to implementing nested lambda functions, the like symbols for lambda functions would be like function one underscore underscore lambda zero, and then you'd be like dot dot underscore underscore lambda zero dot dot underscore underscore lambda zero blah 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 blah. So the lambda bodies like in this type symbol they would like nest into each other, and this made n very large in this one particular instance. So I was like confused why I just like for some reason it took forever to compile lambda functions, but everything else in the program was fine, and it was because of this.
I think it's pretty common experience that people accidentally write n squared and exponential algorithms in compilers. I have written many. No intent, just oops, profiling showed up later and like, oh yeah, this goes exponential.
When it first happened, I was like asking ChatGPT what the problem was, and it was like, "Oh yeah, you're copying all these structures," and I'm like, "Yeah, that made it faster, but it didn't like solve the actual problem here." And I was like, "Okay, yeah, I could just reduce the number of times and like reuse the map lookups, but it didn't fundamentally change the fact that that
Right,
lookup was
right. Yeah, the
two to the n."
the stuff I do with types and interning them is because I had gone down the n squared path on type lookups and type comparisons earlier.
It's
And
not even n squared; it's two to the n, which is far far worse.
no, I know, I know. I managed to avoid the two to the n on the types, but I got n squared, which is already too big by a lot. So fine.
The one that I remember hitting me, I was used to languages like MATLAB and Python that have vectors rather than arrays. And I was writing something in C, and it's like, I'm doing my little for loop, and I'm like, go through the thing if it's less than vector dot length, not realizing that dot length was walking the entire vector looking for the null, was walking the entire array looking for the null. So every
Wait,
time it went through the loop, it went
what
through
is
the
a
entire
vector
first
versus
bunch
an
of
array? I thought a vector would be an indirection to an array with a length and a doubling pattern.
Right. So if you have the length and you say dot length, it just is a read of a register. If you don't have a length and you say dot length in your loop, it walks the array trying to count how many items there are before it gets to a
So
null.
this is a like a C string.
Yeah. And I was walking the string on every iteration of the loop all the way to the end.
Yes.
I think
In order to
that's
test
not
whether I had gotten to the end of the loop.
Yeah.
it's not really a vector,
there's a
right?
nice word for you.
I would have said not a vector either, but I can see this pattern happening. Back in the day, I sure for I equals 0, I less than stir dot length, open close paren.
Right.
Do
I
something
don't
X,
actually want to
stir
call
caret
that
I.
length open close paren. I just want it to get that value once and know it.
Right. And then, right. And suddenly you're
Or better yet, don't get it at all. If I happen to be in a structure that's null terminated, just be like, if the thing I got wasn't the null, keep going.
For C++11, I think calling this dot size on standard list would actually be also a list walk. I think it was only guaranteed to be 01 in C++11, if I recall correctly.
I'm sorry, Ben, what are you saying about vectors? Sorry, I'm like jumping through your conversation.
List, not vector.
List.
List.
List, not
I
vector.
think the size was not guaranteed to be 01 before C++11, if I remember correctly.
Okay.
Yep. List, vector, and array are well defined, except that if you change what environment you're in, they rotate which has which names.
I would have said, I guess on list, though.
I'm
vector.
renaming vector to dinar because I feel like it's like dynamic array. Because I'm like, okay, people come from a math background and they hear vector and they think of something completely different from like a programming background vector. So I'm just dinar is a made up word that's from dynamic array and it conveys the meaning and everyone should understand what that means if they hear the word dynamic array. And it's like no
Everyone
confusion
should
with
know that they don't know
mathematical
what it
vector.
means. Then they'll go check, which is fine. As opposed to Aaron says vector, and I thought Java ArrayList style thing, a doubling array with a constant time length.
Well, that is what a
saying,
vector
no.
is in C++, but like the math people get confused by it because they're like, oh, okay, this is I can multiply two vectors. No, you can't because that's not
math jargon and comp sci jargon are different things.
There is
a math-based startup. That was a known. We sorted that out after a while.
There was a proposal for Swift to add vector, which obviously from mathematics means a fixed size array. As you can see on the thread, there are 272 replies, so there is a little bit of a disagreement.
What did they do?
Yeah, that's why I'm calling it dinar because I'm like, okay, I'm not gonna like this is one of the things I disagree with C++ is like reusing the math word because like it confuses math people, and then obviously there's holy wars over what the word vector means. Oh my God.
Okay, this is like Julia too. So I just read it on Swift. Swift array is a resizable array. It adds an extra layer of indirection. And an unrelated other startup I rarely talk about, I went down the line of fighting with Julia and their arrays that would resize. But everything had an extra layer of indirection, and I fucking needed to do things on the base array at huge high volume and high parallel content, and I just could not pay the extra indirection. That was a free extra doubling of 1 bazillion string compares because the strings were arrays, capital A arrays that were indirectioned. And doing old school TPCH benchmarks, which had billions and billions of modest length strings, and an extra layer of indirection was just killer.
The fun Julia one is
oh God, yeah.
When you run across a single Unicode character and it decides that the strings are all Unicode for the rest of time, so you should give up all your performance.
Yes, that was exactly what I was fighting. Absolutely. And I only needed direct equality. So I just wanted you to be treated as an array of bytes and do byte by byte by byte by byte by byte for 7 to 12 characters misaligned. Wasn't quite what you wanted to do with a SWAR, and it didn't have 128 bits without forcing things, and all kinds of stupid issues there. But the result was.
Quite remember my bug, but I was writing Rust code once, and what I was trying to do was iterate a Unicode thing.
Yeah.
And I somehow ended up in the land of in a loop doing get character at index. But get character at index needs to know how many characters happened before that point in order to count the bytes. So yet again, I had to start at the beginning every single time through the loop and walk until I got to that index.
So you went in squared
because I was walking up to character n every single time.
Yeah.
And in fact, Unicode is pretty easy to advance. If you're sitting at a pointer and you know what index you're at, you can advance by one character and add one to your character count. So there's no actual reason you need to do that. You just have to be careful about having hidden get character.
Define what you mean by one character.
I refuse.
Yeah.
It does point
but it's
out
easy.
That as soon as you say you're talking Unicode, your performance becomes fragile. It is not obvious whether you got the correct answer and you're going to make one pass in linear time and maybe vectorize and do blah, blah, blah magic, or you're going to do two-dimensional array lookups where you walk once to get a length, counting points, and walk again every single time. I personally don't use Unicode because I barely do English. So I fit in the ASCII
I think in the face of all these like conundrums, when it came time to design like some string stuff for my language, I basically just figured I'm not even going to bother having a string type. It's just going to be byte slices. And if you want code points or if you want graphemes or something, just do it all with functions. Like just say what you mean. Like there's so much, nonsense, especially with type inference, where like you could accidentally stumble into, oh, I've got a string of graphemes. Now I need to consult my like locale and stuff like that. All these nightmares.
I would definitely say it's time to get it out of the language and into the library. This is like a job for the standard library now.
I don't know. I really like the syntactic sugar of being able to stick characters that are not English characters in strings.
Oh yeah, I mean but like that's easy, right? Like you can just say my source format is UTF-8, and you have a string literal that has stuff in UTF-8.
Literals for your localization library that.
Well, and then like once you have that, it's like but that still permits being described as like a byte slice, right? Even if you have UTF-16, honestly, not every transformation on that will be UTF preserving, but maybe it doesn't necessarily have to be.
Who fought the UTF-8, UTF-16 war for quite a while in his language.
Do you have any opinions on giving strings identities? So I was working with a library that the original design of the library was you have a hard-coded set of strings that says, if I'm in language N, I'm going to look for this exact English string that I know appears in source code and replace it with that string for the other language. And that worked for a while until we got to the point where the exact same string appeared in different contexts and needed to be translated in different ways.
Yeah.
So now you sit there and it's like, oh, I can't do the lookup because the identity of my string was only the exact character set of my string, and now I need to tag it with something.
Yeah.
And then you end up with
any language translation issue ever.
Structs that are just like, this is a language tagged string. Its tag is 5. Okay, now when you match it, you're not matching against a string, you're matching against a tagged string.
This shows up. I mean, I have seen code written this way where they have some extra hook in the string that lets them, what it's called, I9 or IN9 or something, IN8, swap reliably.
So
I thought you were talking about interning strings. I intern strings all the time so I can skip the string compare. But whatever, the language translation replacement thing, you put a cookie down. Basically.
Yeah, language translation UI is bad. Sometimes I wonder if Linus was right, where he was like, my solution to translating error messages in the kernel is to make them incredibly short and incredibly consistent and use a tiny vocabulary. And if you want to be a kernel developer, learn this set of 50 opaque tokens.
That's not a bad answer. I'm with it.
Your inode, whatever, like that is a word that we made up for this error, and you will learn what it means. Now we are not going to translate the error into 37 different languages. You're just going to learn what this error code means.
The languages you're translating to have no appropriate
obviously not acceptable for user interface.
Yeah, they need a giant long paragraph description to bridge the language gap. Except that the people who are hacking kernel code and know what inode not exist, whatever, already probably understand the thing. Yeah, no, it doesn't need a translation. Too late.
Yeah, we can also like even if you had somebody who was hypothetically not like an English speaker, they still have to interface with the Latin alphabet because of all of the flavors of basically all of programming being like
Yeah.
done this way. And then the other place is you could just put a wiki up that just has translations of it. Or
That's
like today, you could just translate these things and like get pretty reliable results.
Sorry, Ben's comment. Out of memory, cannot load Ian's English description of enomem. Yes. It's all the out of memory errors. Sorry, out of memory cannot give you the error message because I'm out of memory.
That
Yes.
sounds right.
There's a lot of things that fall into this camp. It was the giant rewrite that Sun did. I moved to Azul. Sun did some giant rewrite of the error handling, and they made a valiant effort to say during the error handling, if we catch an error, um, go chase that one down, and then that would cause another error, and we chase the next one down and cause another error. And it was the first time I had a VM crash, it was no lie, at least 10 layers of I had an error attempting to describe the heap layout. I crashed. I caught it. I had an error attempting to look up internal VM structure. I crashed. I caught it. I had an error attempting to look up, and it went on and on and on. Um, and of course, I couldn't figure out my root error because I had so many bugs in the error handler that it was. I probably had a better part of a month sorting out the error handler errors. It was just unreal.
Yes, I saw something like that with, I think this was in the Twitter code base, that as things were unwinding during a crash case, lots of destructors wanted to log information about the badness of their current state.
Yes.
Except that needs memory.
Yeah. Memory and IO.
So if you got into a sufficiently pathological case, it could take a lot of memory where it would like crash and delete things and clean up and then destruct a few more things and then run out of memory and delete things and then destruct a few more things. And...
Oh, you're also deleting as your out of memory handler. You caught out of memory.
Right. People were handling it. We had a few crashes that I think took 40 minutes to fully crash, but succeeded in getting all of the log information out that let people debug it.
Oh my goodness. Yeah, I did this big data startup. I had an out of memory handler that said, nuke the last largest chunk of memory, because you usually ran out of memory when you said, give me a terabyte to hold this giant data set. And I said, no. And so I would delete the last biggest thing and then try again. But I had a short timer on that one that said, if you got a second one of these, you're just dead.
But yeah, handling out of error memories is, it feels like it is an art form unto itself.
Yes. And I reserved, startup, I would reserve a megabyte array. And then in the out of memory handler, where I said I'm going to delete something, the first thing the out of memory handler did is it nulled out the array reference. So that if a GC happened in the out of memory handler, it immediately would get a megabyte, which I was hoping, knock on plastic was good enough that would get me to get a reasonable error recovery out of it.
Windows Task Manager does something like that. It is memory resonant at all times.
Ah, okay.
You cannot get that, I think, 16K of memory back.
Totally fair.
Task Manager is 16K of memory. We will never allocate anything new. We will never let go of the 16 that we have. This is just our 16K of memory.
Yeah.
And if you've got a
Windows Task Manager is fascinating. The guy that built it has a YouTube channel, and he just talks about the route he went for making it. And it's funny. He wanted to depend on absolutely nothing.
Dave Plummer, I think, is his name.
Yeah, Dave Plummer. I watch his channel from time to time. He's a good guy. Yeah. Fun stuff. Dave's Garage.
Invite him on at some point.
Oh, that's a good point. Oh, that's interesting. Yeah, sure. He'd probably be excited to do it. He has some good war stories too. All right. I have a random simple update from last week. I doing separate compilation and reading objects from other file, reading your header info from other .o files is what it's attempting. It's like get rid of the header input thing from C++ land, the pound include headers. but do it the Java way where you go to a class file to load the header info, except the class file here is a .o file. And was getting some kind of bad, very low quality optimizations happening all the time that I was trying to figure out what the hell's going on. And it had lost my free call graph out of the sea of nodes that I get. And so I spent all last weekend, sorting out a better call graph. So I get a better call graph now. That's where I left it last weekend. Was I can read the separate header files from everybody and get a pretty precise call graph as part of building out the sea of nodes calls. So kind of a fun random hack, although it was just only there so that my hello world would not include everything on the planet, but would automatically trim all the other things in the standard lib that you didn't actually use.
So wait, do you actually so do you still have actual includes on some level, or is it all like part of the like if you're reading the header from the object file, is it literally like a native object file? Like do you
Yeah,
stuff in like source or something, or like do you read the definitions out of it? Like how do you
yeah,
store like,
you're
types of
close.
symbols and things?
I write the IR. When I compile a .o file, I throw the IR in it. I
Okay.
compress it pretty nicely, but I throw the IR in it.
I guess
So
LVM
some,
does the same thing with LTO, right?
yeah,
Or at least
yeah,
I'm pretty sure. It's always funny to me that like, you can kind of stuff whatever you want in an object file and it just kind of works. But
yeah, yeah. So I put a dot simple section, and then I serialize the IR into it. And so if somebody else comes along and they say, I'm making a symbol, I call sys.print.code hello world. Well, okay, so sys is baked in as a word that says go look up in the standard lib, which goes to this directory and then looks for a sys.o file. And when he finds a sys.o file, he cracks it open, finds the simple section, sucks out the IR. And then in that IR is a struct called sys. It has a field called print. Print holds a function that does your IO printing. So sys.print is literally grab a global symbol, sys. It's a global struct, has a print field, load the print field out. It's a function, call a function with a string argument, and then it prints. Um, and it does that by pulling up the IR to get the types for print and the type for sys and the type for array copy and types for all the things that you would expect, except that I was not deleting dead things because they were left hooked because I had lost my call graph inferencing of who calls what and everybody called everybody. And because everybody calls everybody, I wasn't getting all the inlining I expected and all everything. So I was dropping smarts about what function called what across
Don't most
these header
.os keep
file.
information about what is external versus internal?
I have a difference between a foreign function and a native and a simple native. So f of I, eventually I call the libc's write call. The print call calls libc write. So that's an FFI call. I'm going to link it against a standard C produced library and use standard C API. And then other things just find the root. You get told when you compile simple. When you compile simple, you tell the simple compiler where the root of your project is. A couple of convenient ways, like the current directory or whatever. You tell the root of the project, and then he does a hunt for missing symbols in your project on a very well-defined hunt path. Which does the obvious things you would do when you're hunting for symbols. It just looks all the nearby places. And if he finds a matching file in a well-defined order, he gets the .o and cracks the file open and sees he's got a pre-parsed, pre-assembled, pre-compiled thing. And then the pre-compiled thing has all the type info. Plus it has the code you're going to call, and then he can make a decision to inline and things like that. So it's link time optimization, but it's also including the pound include header info so that
Simple
you
doesn't
don't get
currently have
contained
a
pound includes.
REPL, does it?
Sorry?
Does Simple have a REPL currently?
Not currently. On and off, I've had one functioning. The distance between where it is and a REPL is really short. It's literally you would write the read and the print, and the print has all the prints built in. You just need the read, and then the eval is right there.
Because having a system where I can say build and it will turn all the code into an artifact for me, or run and it will turn all the code into an artifact for me and then call main.
Yeah.
Or Repl, where it will turn all the code into an artifact for me, and then instead of calling main, just drop me in an environment where all the symbols exist.
Yeah, I have the first two already. There is a build it all, and there is a build it all and run main.
And there's something nice about saying, look, just don't run, get all the way to the point where we were about to call main, and then just drop me in a Repl.
Drop you in Repl, yeah. So it's not far. I mean, I could step you through it if you wanted to do it. I'm trying to sort out the last bits of separate compilation so that I can go after my standard library without having to have it be compiled. What I was doing, a month ago was it got all of the standard lib compiled with everything. That was expensive. And once I get this chapter done, I think I am going to attack it with AI and see if we can't clean up, simplify, add better docs, all that kind of stuff. A lot of good things with AI to be done here.
Yeah, I think those are all good plans. And I'm very curious to see, as we start writing the standard library, where you find things that can be pulled out of the language and put into the standard library.
Could be. I don't have a whole lot in the language now.
I'm thinking about languages like Go that started with print to standard out as a very built-in part of the compiler.
Oh.
And then they moved it all into the string formatting library once they were mature enough to be like, we don't need print to be part of the language. That's dumb. Like, if you want to call a function and not hand it standard out, don't hand it standard out.
I started
that means print better not be built into the compiler.
Right. I started with some kind of print for debug purposes only and knew that it was always ever for debug purposes. And I dropped it somewhere around chapters 12 to 14. And then I started adding things to do print of a string. And I wanted for an FFI call so I can call write. I needed byte arrays. I needed small integers to get byte arrays. I went through this long sequence. It took like 5 chapters to build up to having a basic string piece. And then I can print it. But it doesn't do UTF-8 or anything like that. It just takes a quote and reads some characters, declares you an array of cars. It fixes like the whole I'm a string thing is going to be standard library stuff. And I guess the one hook I'll make is you say quote, and then you do some stuff and you close the quote. That'll have magic knowledge that there is a string type in the library somewhere it's going to refer to get a string constant out for free.
Yeah, I'm fine with magic syntax that refers to a thing that's in the library and just be like, open square bracket, close square bracket implies the existence of a thing called list. What the symbol list means in your context, that's up to you.
No, death to list.
Open brace, close brace. Oh, that implies dictionary. What dictionary means in your specific context?
Dictionary I'd have to sweat more over. List I could shoot.
Why don't you like list?
As a data structure, wildly inefficient. That's the only reason.
No, I mean as a object literal in the syntax of a language.
Yeah, only because it would encourage you to write this horribly inefficient code. There's no sensible reason.
You're thinking linked list.
I know, and if instead I thought in my head a resizable array, a vector-like thing, what C vector, Java, ArrayList, what the fuck vector means. Yes. Then having one of those free in the language is probably actually a reasonable idea.
Yeah. I want syntax for this is a sequence that is indexed by a number, or this is a unordered set that is indexed by a string. Go ahead and give me literals in the language that say this is string to object, and this is index to object.
Yeah, that's not a bad answer. I probably should do that. Goes hand in hand with
those literals are really nice. People know JSON. The ability to just like stuff JSON strings into your language and have that become something reasonable is really nice. I like those object literals.
Ecstasy has that. Or
you have a string type.
Yeah, I mean it has literals for maps,
true, false,
lists, and JSON.
Aaron, let Mark finish. Somehow you two.
Yeah.
overlap.
Sorry. Yeah, so I mean, it's been a while since I've played with Ecstasy, but it has the equivalent of dictionary literals, list literals, and then I'm pretty sure it also has like direct JSON embedding support and maybe conversion between the two. Yeah, it took me a minute when I saw that for the first time. I'm like, okay, yeah, why not? These are common data structures. Why not have a literal way to represent them?
Yeah. Okay. Lists and dictionaries I can get. JSON, I have to think about it, but having you said it, of course, it's like fucking everywhere. So sure. Ooh, it's probably a tiny bit of syntax. We'd like to sort of generify that. Say you can define a syntax with a special operator that includes a quote and something else, a J and a quote. And I'll do a lookup in the library for a J quote thing and hand it whatever string came out of that, and that'll turn into JSON embedded, blah, 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 whatever. Yeah, Aaron, there you go. Null, true, false, float, int. UTF-8? Don't you have int in there? I'm looking at your JSON chat.
JSON does not have integers. It only has float 64.
Oh, really?
Yeah. The JSON value 3 is the float 64 3.
And the JSON value 1, 2, 3, 4, 5, 6, 7, 8, 9 turns into some float that rounded off and lost the 9.
Well, it's a double, so it's you got your normal like 52, 53 odd bits of integer precision.
Okay.
It's like this because that's how JS is specified.
And if I wanted to do a true 64-bit like a UUID.
So JSON has 53-bit integers. That's what we're saying.
Yeah.
I think it's a little tricky because it's part of the float, right? And it's 52 bits of mantissa, and then there's the sign bit, and I think that essentially gives you 53 bits of precision, right?
Yeah.
But it's it's a sign bit, so it's a little different.
Should be enough for anyone.
But I can't have like two 64-bit integers for a UUID.
Yes, which is like, I think the recommended solution is like basically just put it in a string with like hex, which sucks, or like base 64, which is not so terrible, but it's still not great. This was a kind of when I was working on JS, this was something that came up a lot in that like people would be like, hey, it really sucks that we don't have like an int64 type. And at a certain point, JS itself added like big integer. And so like theoretically, JSON, if you're using it within JS, I mean, it's not JSON really at that point, that is the solution that JS went with. But even then, it's like, half the things that people actually want big int for are just int64. It's one of these big gaps in the language.
I've definitely heard people talk about, should we replace JavaScript object notation with like TypeScript object notation that includes big int and byte array.
Yeah.
Oh, and like infinity as a keyword and NAND.
Yes, you can put infinity and NAND into JSON. You just can't put a 64-bit number.
I'm sorry, infinity and NAND are not normally in JSON, right? Because I've dealt with a JSON parser before where he was pedantic and wouldn't take infinity and NAND. And I had to deal. Yes, because I need yes. Whatever the hell came out. No, I'm doing some big integer math calculation, and for whatever reason, I have to pass through a JSON thing to hand it off to somebody else. And some part of the math did a divide by 0, and I got an in. And now I want to tell this guy.
Trying to multiply by 2 to the 255 minus 19 for reasons.
Yeah, any number of things. Usually the story was they were trying to do a logistic regression on a data set that had extremely low value content, highly parallel, semantically parallel data sets, which meant that the deltas between them was being used to drive the logistic regression to a solution were minuscule, and then it would divide by 0 at some point.
Twitter had a fun bug once when the float rounding of one user's user ID landed on another user's user ID.
There you go. Oh, that'll happen in my current startup. I can't do.
Oh yeah, Twitter user IDs are 64-bit numbers.
Yeah.
Technically,
I love the idea of having user IDs as floats. That's That's
And I
great.
divide this user by 2.
I mean, if you're careful about it, you have less than 2 to the 53 users.
Yes. As long as you're careful about it.
It's fine as long as you just
Yeah.
but that's not how the Twitter user IDs work. Those are
So there you go.
63.
No one would ever, when you began Twitter, dream of you'd have such problems. This is why these things exist. Because when you start out, you're like, God, if we got 24 users, not 2 to the 24, 24 users, that'd be really cool.
Yeah, we'll splurge on a short.
We'll splurge on a short. Absolutely. I was C2 thinking, I was like, God, I'm getting these Java bytecode methods. They're not that big. Speed, I got tiny processors. I need speed issues.
Have you ever read Vint Cerf's memo on the number of bits in the IP protocol?
I'm sorry, what about the number of bits?
Vint Cerf has a memo about the number of bits that are going to be in IP.
Yes.
And they're doing this back of the envelope calculation of like, there's about 2,000 universities and they're all going to need a computer. And there's about 2,000 military ships at sea and they're all going to need a computer.
They're all going to need a computer.
And there's like 500-ish large private boats. And then there's thousands of companies. We think we're going to need an internet that can support at least 8,000 nodes. So 65535 feels a little too close to 8,000 for comfort because something we don't know is going to happen. Yes. So we're going to use 32-bit because that's going to allow us to have 4 billion computers on the internet.
Yes.
Turns out
something might happen.
When your back of the envelope calculation was 8,000 computers on the internet, 4 billion was too conservative.
Wow. Awesome.
Now we have the IPv4-6 transition.
Yes.
It's funny.
You could probably find buildings in like any major US city that have more than 8,000 different connections going on.
What? Say it again.
Yeah. You could probably find buildings in major US cities that have more than 8,000 nodes. Or sorry, yeah, a building.
Yeah,
like a skyscraper.
Oh, yeah. Okay.
Yeah.
Yes.
A bunch of phones, a bunch of computers, they're all routed to a bunch of these giant switches and stuff like that. And they all have to go together because, you got to reach the ground at some point.
All right, fine. Does like the
but
World Trade Center
it
towers.
Might have been nice if JSON had a unsigned int64.
I'm sorry?
I said it might have been nice if JSON had been born with an unsigned int64 type.
It might have been nice if Java didn't have finalizers too.
One of my former coworkers who was active on TC39, the ECMAScript spec, said it would actually have been preferable to have int64 in place of big integer, because no one actually needs big integer and it's slow and it's like there's only a few little applications where you actually need like greater than 64 bits of precision. But the fact that you don't have 64-bit is just like any interface with any language, especially like even within JS now, you have WebAssembly where I64 is like super, super common, and every single one of those has to be done with a JS big integer now. And so you need an allocation to go back and forth and call your JS APIs and stuff like that. And none of the big engines can even like inline across that boundary. So it's just kind of this mess.
See, now that's a Coffee Compilers Club question. What would it take to actually clean that up?
To do the
64-bit integers where a big int is
just add 64-bit integers into the language.
It's for JSON or something. I think theoretically as a data interchange format, like it wouldn't be hard, but JSON is popular because it's so simple. So like you probably just wouldn't do that. For JS or like other languages with this kind of problem where you have like F64 as your number type, it is a lot more complicated because you are essentially adding to your giant like runtime type lattice. Yeah. So like addition in JS is this horrible nightmare function where like anything can add to anything, right?
JS,
so like the number of
JS shot itself in the foot repeatedly.
I mean, I think
so
there's
I have no sympathy for JS.
I think there's pros and cons to it. Like I think there are certain things I respect about JS, and that while it is confusing, it is also in some sense like fault tolerant. Like if if every website ran Scheme where you have super strong typing, I feel like a lot of your websites would just crash.
No, they
which
fixed
is maybe
bugs. They
a little
would crash
questionable.
and fix
well,
bugs.
I feel like this is a kind of idealistic view of the web where it's like, yeah, web developers would notice that something is broken and fix the bug. And then you look at any website in your developer review and there's like 20 exceptions. And it's like,
Yes.
this is like google.com or something. I mean, I don't know if it's literally google.com, but like big websites with tons of engineers will just be like, yeah, we just break a bunch of stuff at startup and it's fine.
Yeah, but
Um,
I feel like some of that is like born of this kind of behavior. Like Java had the same kind of
some of
problem
it.
where you had a bunch of you have a bunch of Java programs that'll just like throw an exception and then print the stack trace and then just keep running as if like that exception didn't matter.
Right.
Because it's really easy on like Eclipse or IntelliJ to just, hover over it and say, hey, just like print the stack trace and then keep running or something when you catch an exception.
Just this mindset for the whole exception throw. So I run IntelliJ on Windows, and it comes up and it does its thing and it works and it's great. And I run IntelliJ in WSL, which is basically a Linux container, and it spews exceptions out to the standard out just endlessly. So there's like a vast count of exceptions come out, and then after about 2 or 3 hours, it'll crash. Now, what exception in there was the one that dictated I should crash now? Out of the thousands, tens of thousands of exceptions that got thrown over the course of my 3 hour session, what the hell was anyone thinking there through any of them other than the one that actually brought you down? Ugh.
Yeah, I mean, I think like there's obviously a strong argument, and I think this is, it's been made many times of like it is good to make these things unrepresentable if possible. I do think though, like JS is not, like some of the things that it does are kind of unacceptable. But for the specific case of like numeric types, I think I will say like being quote unquote like weakly typed, right, is kind of your equivalent of like subtyping. Like something like Scheme will even do this. If you add like a float and an int, right, it'll have a numeric tower. And so I think, like there are reasons why if you have a dynamic language, which you can question why a dynamic language would ever be useful, but like some people like it, evidently.
I thought.
Then, it does make all of your arithmetic like just complicated. And also, of course, none of this makes it into the top tier. Like once you hit the top tier, all this just goes away, right? And so like your implementation complexity goes up because you have this bigger type lattice. But once you hit top tier, it's like everything's probably integers almost all the time anyway. But we found generally like your performance, just because there's so much code that gets compiled in a short period of time, especially on like within a browser or something, even your like baseline JIT performance or even your interpreter honestly like does come up. It's like it's not the majority, but it's like in your first like load time or something, it can be like 30% of your performance is spent in the baseline tier. And so if your baseline tier is checking an extra branch of am I a 64-bit integer, you've just now multiplied your performance down, X percent.
I'm thinking
Um,
that's should be reasonably solvable by moving the big integer off to the ever more rare path in the implementation. But to make that work, you have to do a bunch of implementation work. It's
well, and they
not
definitely
trivial.
do, but I think it's like, even
No,
then, like you
Aaron, no.
have to actually do the check, right? Like there's some point where you have to say, I've definitely detected that I am doing this thing, even if it's, like pushed down into some slow path. Or even it just makes your code size bigger also. So like you have to actually emit that check somewhere of like go to
Yeah,
the slow
yeah,
path.
yeah.
I mean, I don't have the numbers of exactly how
Let me
costly it would be. I think
let,
another aspect is just the implementation complexity also
let me
counts for
throw
a lot
Aaron.
because like
But see, Aaron, I'm just going to claim this is why JavaScript should be shot. Let me pull this guy out here. God damn it. See, 100,000 things. Open. Shares. It's just in the chat, but I'll throw it up for people on the video here. This 5.0 as a float ORed with 0.
Bitwise OR.
Get bitwise OR. Yes, bitwise OR gives you 5. And that this equals is an equality check of some kind as opposed to an assignment.
No, I'm merely commenting that in JavaScript, bitwise comparisons are fundamentally 32-bit operations. So if you ever do a bitwise comparison with 0, you force the thing that comes out the other side to fit in a int 32, which means that the compiler can make assumptions from the future on. So if you would like something to be an integer, just instead of initializing it as your number, don't be like 5, be like 5 or 0. And now you've signaled to the compiler that it is in fact a 32-bit and it can continue on with its 32-bit optimizations from there.
This is
yeah.
like
It's
undefined
a shocking amount of
C.
performance can be gained by adding or 0 around your code that do nothing.
I would say not so much these days. Most modern JS engines will just figure this out. Like if you use something like an int, they'll just know that you used it like an int, and they'll do the int thing. You have to like overflow that int somehow to mess with the speculation in the higher tiers so that it
Is
actually uses a float or
overflow
something.
32 bits or 53 bits?
Most of the engines do. It's kind of complicated. Most engines heavily optimize for
And the
32-bit
fact
integer.
that you address that question seriously says something.
I mean, it's the combination of JS being this weirdly defined language. Although honestly, like, if you were just making a JS interpreter, you could mostly ignore all of this and just be like, I'll just treat all these as floats
I'm
and
just
I'll
going
be
to be
fine.
slow and I don't care.
Um, so the story basically is some engines. I don't actually know what each engine individually does. They all do some sort of 32-bit optimization because that's, register
Obviously.
size, and so
Yeah.
it's just generally faster than doing whatever like a 52-bit integer is,
Yeah.
and maybe having to convert back and forth. But some of them still do that. I think it was like disabled by default on the one I was working on. I don't know if V8 does it. Um, but like there is maybe some optimization potential where some engines will actually like speculate like, oh, well, I had this integer that overflowed 32-bit, but when I did that overflow, I still checked that I was within the 52-bit range or something. So I'll emit like an int 52 operation, and that's still maybe better than using the float for some sort of horrible reason. I'm not
But
sure
those
that's actually
64-bit
true.
registers, any modern processor, all 64-bit registers.
Well, so I think, but also floating point is pretty fast, so I think the margin's pretty slim,
It could be.
It's
Good point.
and
Yeah.
you've got to go back and forth every now and then. Like I don't know that you store things as a 52-bit integer in data, but like maybe you could. I think this was kind of like frontier optimization potential that hadn't really yielded a lot of results, and so it was just kind of disabled by default, in my experience. But
Yeah. Okay.
theoretically, like some engines try to do this, which is funky. But a lot of that is, very invisible to the actual like runtime semantics. It's more like this is purely an artifact of the higher tiers, and so you get your speculation info, and it's like, you can just choose. Oh, actually, I do want to think about int 52 as a type that exists. Um, yeah.
Okay. Oh, what tangled webs we weave. Hmm. All right. What else?
I have a like maybe simplistic topic, although I don't know, kind of related to some stuff we were talking about earlier, which is I was trying to I've been juggling a bunch of different like features in my language I've been making progress on, but one that I have not really broken ground on yet is string formatting. And obviously, writing a function to do string formatting is not that difficult, but I wanted to do, like Pythonic, like format strings where you have like a string literal and you've got some braces and stuff in there. The conundrum that I've been running into is not really necessarily a real conundrum because I think there's an obvious fix, which is for anything like this, you could pretty easily implement it with like some toString method and like a string builder, basically, right? Like you could take your format string and turn it into like some, string literal segments, and then you've got some values, and each of those values you say, I'll call some toString or display function on it, and then I'll like concatenate them all together in some vector and allocate some final string. Um, I was mostly, I'm sort of wondering, does anyone have any ideas for, is there a better way to do this? Is there some way I can make this simpler? Like I'm making this, nominally low level systems language. And the idea of kind of implicitly allocating this vector where you like add a bunch of strings and it maybe does multiple allocations and like resizes itself feels like a little gross for like a language feature that's built in. But
No.
it seems like maybe the
Inside your
most
string
reasonable way to
literal
do it.
variables or thunks?
Sorry, what?
Do you want the things inside the parentheses, excuse me, to
Oh,
be
there's just any
variable
expression.
names or arbitrary code?
Just any expression. I mean, I mostly don't think that's a big problem because, you can very easily go from expression to just create some temp variable or something.
Okay.
They'll be evaluated once.
So there's like these bunch of different people do this in related ways, and I would kind of survey and see where you land. Having a string builder as part of the semantics, when you say I have a quoted string and it has, I say
Yeah.
quote Alice plus quote Bob, and I do the plus, and I don't want to concatenate by copying Alice into a new thing and adding. Um, Declare yourself essentially a string builder. When you say quote Alice, it gives you a string builder, not a string.
Yeah, I know this.
and
I
then
know this
have
is like what Java does, right?
conversion. Java does it as strings, but the compiler optimizes under the hood. As soon as he recognizes you're
Okay.
doing a bunch of pluses, he secretly injects a string builder.
A little interesting that it's not done like lexically, but I guess it doesn't matter that
I
much.
think it's done by C2. Or at least 2 years ago, I talked to a
Huh.
guy who was working on that. I don't know
That
what
seems a
it's on.
little weird. Like I wonder, like, could you not do that in the front end? Is there some weird reason why you couldn't?
Maybe you could.
Interesting.
Semantically, he still has to act like a Java type that was always ever. So you said quote something quote is a Java string, period, end of statement, and always in cases, right? You can't change the language spec now. Okay, now I'm doing math with the string, and when did I lift it at the type level so that the bytecode level I can spec and see that I had a string builder? You can't do that in Java because the horse left that barn. So C2 secretly lifts it behind your back as a compiler optimization. I don't think you need to be
Hmm.
secret there. I think you'd be fine saying it's a string builder.
I think it would be relatively easy. Like I don't really want to assume the presence of the standard library, but I do assume the presence of some sort of allocator. And so I think, there's some way I could, it would not be that hard to even just emit inline the IR to do like a vector push or something.
But we'll admit the
Um,
existence of a small subset of the standard library that you always include every time when you build something.
I mostly don't want to, but I think I can still get a lot of the benefits of that. Like a lot of these things I specify in terms of essentially traits. Like I'll expect that, oh, you can call some standard method name or something. And there's no default implementations of these. Actually, there's a couple, but like they're not actually defined in source. Um, but I think as long as I have like some hook where I'm like, oh, if you try to iterate through something, it'll like try to call its iterator method or something. I think that achieves a lot of the benefit of including like a prelude that would maybe defines a lot of the stuff for you. But I want to keep the language core pretty lightweight. Um, but like I said, I still require an allocator.
Do you
Let me pitch.
floating point math in the language?
Floating point math is all hardware,
Yeah,
right?
square root.
Oh, I currently haven't really messed around with numerics. Like I think I'll just make that a library. Like I don't know if they're that important
That's
to
fine.
not put in
That's
a
what I was
library.
wondering. How big is your prelude? You were saying
How
it's
big is my
nothing. I
what?
have no prelude, and I'm like, okay, let's probe at that.
I have I basically have like a pretty minimal like runtime. Like I have my equivalent of like libc, but it's much smaller. And
But
so it's
yeah,
essentially just
yeah.
syscall wrappers and like a
Right.
couple
You can
niceties like
call standard out dot printf
yeah.
print
And
your
it's
argument printf.
like not even printf, it's literally just like write,
Just
right?
right.
But
Yeah.
like
Okay. Yeah. You
but it's
want your
basically
argument
those plus an
formatted. Yeah.
allocator.
Do you
Um
include string formatting in your prelude?
so I think basically the question would really be like, what's the interface to this? And I think there's a couple options. So one of them would be, basically when you write this like string literal in your source language, it essentially emits calls to like toString or something. So like that's one option, right? I wouldn't necessarily include this in the prelude, but the compiler says, well, if you put a value inside a string literal, we'll assume you're trying to call like a toString method or some sort of conversion like that, and
Hmm.
we'll expect that whatever type that is implements that. And then maybe some could have like a default implementation somewhere. I do have some capacity to insert some of these primitives.
You're
I
doing
think
you're doing formatting where the expression is injected in the string literal as opposed to a printf where you're hunting for a percent sign or some
currently,
like
yeah. I mean, like I think it's kind of nicer. Like it's
yeah,
the way
it
Python
is.
does it.
This is like a
I'm
Java doc because XTC does some of this that looks good to me. I know Python does some of it too.
let me float the alternative I was thinking, which is
Yep.
and some of this is maybe like splitting hairs, but I think the real thing that kind of bugs me about like, toString and like a string builder is it involves like multiple allocations potentially, like kind of an like unpredictable number. I would really like it if possible to be like a single allocation that just happens once. And I think the obvious path to basically achieve that would be, as part of your trait that you expect, like instead of just say like I should be able to convert this value to a string, right? Um, you instead have like two methods. One would be maybe like measure, where it basically says like, all right, if I were to format myself, like how many bytes would I occupy? And then you have another one that's like, actually like write my contents into some buffer. And writing stuff into a buffer I already have. That's how my current like println works and stuff like that. Um, So the real thing is just this like measure function. Like, you would like basically the way this would work is you'd have to like iterate through all of your like formatting parameters, and you'd have to like actually measure their length through some algorithm, which is not too difficult. But I mean, I've been kind of going back and forth on this. Like, if you're just assembling a bunch of strings into a bigger string, this is basically trivial because you probably know the size of your string. At least, in my language, strings generally carry their sizes with them. Um,
Do a
and so
string.
you could, like add up the size of every like individual part and create some, unified buffer that's exactly the size it needs to be, and then write everything into the buffer in a separate loop. And then now you've only done one allocation and you've just called a couple extra methods, but maybe those methods are really trivial because they're just getting the length of a string. But on the other hand, if you're trying to format like a float or something like that, figuring out the length of your, formatted output is basically equivalent in complexity, I would imagine, to actually just doing the formatting in the first place, right? So you're kind
Yeah.
of duplicating the work, um, which so this is where I'm kind of curious what thoughts are on this. I think, maybe this could be acceptable. It is kind of trading off like the overhead of allocation and maybe some extra, I don't know, memory throughput or something in favor of doing more like probably CPU work to do like, maybe double the formatting work for certain
Array
types.
doubling things are cheap. Just do it. Don't
Okay.
No, but
try
you're
to
you're
sort
talking
out.
about serializing to dev null, right? And counting up the bytes effectively.
Basically, something like
Yeah,
that. Yeah. I
I
mean,
tried that years ago thinking it would be such a major win, and it was not very noticeable in my case for exactly the reason you're suggesting. It was you know, basically I serialized to a dummy stream, and that was too much CPU to be worth the perfect buffer sizing that I got out of it at the end.
okay. I mean, I guess so
So
the thing I would specifically avoid is I would require that this is like a separate method. And so like the idea would be in most cases you never allocate a dummy string, but you're running through your formatting code to figure out like were I to format, how many like digits would I have to output or something like that.
that was,
But
like I allocated a
that's still
dummy
not
output
cheap.
stream, right? So that was like a tiny allocation. And then, I was able to use standard serialization to get an exact amount. Again, going back to Ecstasy, Ecstasy has something like this, I think specifically for its equivalent of toString, where like you have to implement this stringable interface to have a toString. And if you implement the interface, there's a secondary method that you can implement that lets you guesstimate how big your output will be. So if you bother to implement that, then like
So
it can
It's not perfect
pre-allocate
though,
what
right?
you need.
It's an
What's that?
estimate, not a perfect.
if
Right.
you're
Yeah. It's
This is like you're saving an asymptotically small amount of effort to get a buffer that resizes one less time.
yes.
Right, right. You go from if you do the doubling, the buffer goes 1, 2, 4, 8, 16, 32, blah blah blah, powers of 2. You chopped off the low order doubles, but they were all the cheap ones.
I mean, I think
And your
there's
estimate was close. Your estimate was correctly close.
it sort of depends on what you're doing. Like I could see a lot of cases where this would actually be like, potentially really fast. Like if you're mostly doing string into other string formatting, like if you're really just doing like the string addition like or concatenation
Yeah,
case,
yeah.
like, then measuring the strings is just it's a single load, right? Pretty much, and probably a load to something that may have been populated recently. And so, like in that case, I would expect that you might win. Like if you do a handful of loads versus the cost of doing another allocation, and also all the branching and stuff you'd have to use for a vector. Um, but
Vectors should not give you a lot of branching. You should.
well, I think it's going to be more than like load the length field of 3 strings or something, right? Like
It,
every time you concatenate to it, you have to like do your growth check.
yeah, you do growth right, but that check
So you're
should.
only serializing the primitive values. You're not serializing a generic object graph.
It could be theoretically any type, but it's an arbitrary method call, right? So if you're
So you want
serializing
to
something, you
pass
expect
you want to
that
pass a tree to ask it how big the tree is, and then pass the tree again to output the data.
Output. But
it
see,
would be basically double the iteration.
you can't
And
run
so yeah, that
this.
could be slow.
You can't
Yeah,
run the
okay.
code
Can I just make a
twice.
suggestion? Just get your compiler to output a toString with no parameter and a toString with a buffer, and the toString with no parameter just creates a buffer and calls the toString with buffer.
I mean, the thing with the
And do
buffer
that
is
everywhere.
like, I think the big question is just what buffer should it be? Like
Okay,
my
wait.
initial thought was
It
like
doesn't
I
have to be
want
a
to try to
buffer. It
make
just has to
something
be with an append. Literally, just append
Yeah.
a primitive,
append to
and that's
something.
the only thing it
It's
does.
append of
Because
primitive.
then you can pass the console out, and it will just append straight to console out.
I'm having a different problem. If I have a toString call, it does arbitrary math. Does any number of side effects. I can't call it twice.
Well, so this
It
is
does
why
side effects.
I think
So
specifically I would have to specify this so it's two different methods. It's like one is like format myself and the other one is measure myself.
I think
And
yeah, I think
theoretically
you're
these could
asking
be
for a lot of grief. I would just
okay.
format it once into a global buffer and pay the grow checks, and the grow checks are just cheap.
If
Right,
everyone
but
is
I think
like
the key
yeah.
thing is the suggestion that just came up, which is have a if we're talking like Java and we're talking a toString method, you don't want if you're going to call 12 different toStrings, right? Now you've done 12 different tiny allocations of throwaway strings. Instead, have a toString that takes in a
Oh
char
yeah.
buffer,
Yeah.
I
right,
think
and
those are
append to
easy
that, and then
to
have the
dodge.
zero arg one
Yeah.
call that, and then you get the asymptotic growth that Cliff was talking about, right? Like
That's how
perfect,
I do
and
it
it's
internally.
one implementation. It's easy, and it's going to be cheaper than
No, yeah. That
doing
is
a
already how I
serialization once or
formatted.
all of
twice.
my toStrings. All of my toStrings has one that just creates the buffer, calls the one that takes the buffer, and then calls toString and returns.
That's
Because
exactly
if you're
what I
calling
do.
that,
Yeah.
you get the string. Everything must implement its toString via the one that takes the buffer, because then you can just do things that you want to do and you don't have these minor allocations.
Yeah, and then no one should ever call the
Right.
version that returns a string, right? You
Yeah.
you want the version that takes a char buffer to return the buffer. Right?
Yes.
It actually,
This is already how my code works.
in the land of Java development, the toString one gets called by default in the debugger. So I always have the toString that's the official one, so that I can just hover the mouse in the debugger on the variable and the
Yeah, sure.
fully
Yeah, calling the
predefined.
expensive one for debugging, sure. Who
Yeah.
cares?
But then under the hood, everyone implements the one that Ben's talking about. Yes.
Yeah. I guess I'll say I do actually like so this is already how all of my IO is specified. The big thing is you don't know the length of you don't know how much you're about to format up front, which means like allocating the single buffer is difficult. That's that's the chief problem.
No, but
in terms
if
of
that's
dodging
throwable,
all the smaller allocations, those are I think pretty easy to get around, and I would not have to do that. The way I
right,
actually
but to Cliff's
specify it
point,
is
right? That buffer is growable, and like you
yeah,
pay
it's
it
just
off pretty quickly, right?
it's less even it's partially the performance, but it's also I think the thing that kind of squicks me out is like it's kind of spooky action at a distance. Like
You should
the amount of
measure that performance before you claim its performance.
well, what I'm saying is I'm less worried about performance than actually just like language complexity. Like what is the compiler depending on? Like does this mean that I need to include like a vector type that's like user available in my prelude or something? Like I currently, as I said, I don't currently have a prelude.
But might as well be, because it's going to be the same thing the user's going to write anyhow.
Well, yeah, and so this is, like now it's like, do I need to add a prelude to my language just for this one feature? And that starts to get kind of icky design-wise. So it's less about the performance and more about like this is kind of a lot of baggage for the specific narrow application
you
of.
don't want it in your standard library. I'm throwing that in my standard
I would
library.
rather have it in my standard library. I'd rather someone pull it in only if they want it.
But I am willing to have the parser have secret knowledge of things in the standard library and say, oh, you're writing out this dictionary vector literal. I'm not going to generate a dictionary from the code in whole cloth. I'm going to call libc or
So far I've
simple.sys
stuck.
and say, make a dictionary, throw some fields in.
So far I've stuck mostly to like just kind of a common like method name protocol, like basically traits. I don't really specify any data that's expected to exist other than like primitives, of course. And so like everything that I do that currently relies on like quote unquote the standard library is like I expect a method with this name and anything can implement that because my language very easily supports like extension methods from anywhere. And so like,
So there's
like
I'm asking Aaron's question. Is there a way to make an array of literals? I want to put the first 100 primes in an array and just write them out.
this is actually another thing this is very related that I think I was this is another thing that I've been thinking through recently because similar to this like this string formatting problem is also kind of like I want to do something similar for arrays. Like I have array literals, but currently they're just very basic arrays. You provide a value for each element. They're fixed size. sort of by this token where if you define some interface to, splice together a bunch of strings, and I think it's a little simpler in the array case, but like it would also be nice to have like array literals where you can pass in like an arbitrary iterator and like unfold that and splice that into a list or something and get like a, you know, slice out or be able to
Yeah.
pass that into a custom container type or something.
There's
And so
a
that is another like interface question that I've been
there's a
thinking
happy
about.
bottomless list of cool things to go add.
Which I think is, I think this is also like the array case is, I think, quite a bit simpler. I think for one, it's easier to justify even potentially requiring like, if you add something to my array, it has to implement not only like iteration or something, but also like a size method. And usually I think that's more innocuous than like the length of my formatted string, right? Most things can figure out, oh, I'm either trivially one element or I'm like a list with some elements, but it's complicated with like iterators and stuff like that. Um, I think the other thing is like even this could theoretically be just like a method. I think my type system and general method system is capable enough that this could be like a variadic generic method that I just expect to exist. But in general, there's sort of the general quandary also of like, well, how much of your language should expect that certain methods exist and assume their existence and call into them versus there just being certain primitives that work in a certain way and are very concretely typed.
So
Um,
Java's var args is done by assuming the existence of an object array, and he jams the args into an object array. So he does assume an array to do var args. So I'm just saying there are some big languages that have assumptions that the parser knows secretly that there's other implementations floating around.
oh yeah. Well, and I think the way that I would do this is, or the way I would plan on doing var args is essentially just a template that takes a tuple. And so, there the compiler fully knows like all your different types and it can dispatch statically on the types. And so I think that's at least like pretty proven in terms of just, you statically iterate through this tuple basically and you get kind of the fastest version, like the fastest possible version. Same way that C++ does like
Yeah.
formatting or like the newer versions of formatting. Um, but I think generally it is kind of this like open question maybe of like there's certainly some languages that very heavily index into, well, everything can be extended by the user in some way. Like every operator is overloadable. And then you have
These are the
languages that take the
AA,
opposite extreme. Um,
which is
okay, so this is one of the things I was kind of
fun.
wondering about. Because I was using Java for the first time again recently, and I was like, okay, here's a language that clearly gets away with not with essentially none of this,
Yeah,
to the
yeah,
point that like, I even like redid the like rookie mistake of like figuring out the equals equals does not call dot equals, like all these funny
yeah.
little kind of scheme-esque things. Um, so I've been trying to figure out like where exactly I should land on that. I've been very like conservative with this so far in my language, and so like there's a couple things that will there's a couple very specific syntactic constructs that will ask for a certain method to be called or something like that, but you can't like overload accessing indexing into a vector or something or comparing two things
What
currently.
I did for AA's operators is that there are some base level ones like array lookup, and you can overload the array lookup operator, but you can't replace the existing array overload. You can just shadow it.
I think that's probably a good way to do it. I mean, all of my extensions are done through basically overloading in the general sense of like, multiple methods exist. And so I think in my case, if you were to even touch like, overloading something for slices or something like that, that maybe inherently involve like inherently implements indexing or something.
Ben, I think you're
Um,
going backwards here.
oh man. Um,
I
I
see
think
the
I
chat
think
going
I
crazy.
think typically if you were to confuse these in my language, you'd basically just get an ambiguous overload resolution error. And so it's hard to like replace the implementation.
That's what
But
I do.
currently I just totally dodge that. I'm like, yeah, the only thing you can index into has to be some subtype of like slices because that is my
The
array
obvious big
interface.
winner for the overloaded indexing operators for dictionaries, where you can have square brackets with a key that's not a number.
Yeah. I think that and also like I mean vector is also just if vector is a user defined type, people will still probably use it in many of the cases where they would want to use some kind of array. And so like in the same way that like Java ArrayList, like it's kind of a pain to have to write like .get, right? You
Yes.
are not implementing the same methods. Um, So something I was going to ask about, like, I guess if you do this in AA, has it influenced your type inference at all? Because that's one of the things that kind of
Yeah,
spooks me about this, is I think, theoretically it's possible. Theoretically, it reduces to just doing an overloaded call, right?
right.
But it is kind of a lot of stuff where, like, if you have this thing that's super polymorphic, like a overloaded call, like maybe your type inference takes longer. It's harder to evolve all the information to actually like resolve that. You need to get the information probably from a different
I
source.
definitely worked at the type inferencing piece a bunch as hand in hand with doing the overloads. Um, I did them maybe a different way than other people do it.
Do you have any
I
tricks?
made
I'm
my
kind of
type
curious to hear
system
them.
somewhat stronger than people normally use in order to have the array overload sort of be transparently possible. Um, the the actual overload, the overloads are implemented with a thing that turns into sort of a beefed up version of type classes, essentially. Uh, I can infer which field you mean amongst a set of fields. I have a struct has a bunch of fields.
Hmm.
You use something out of the struct. You don't name the field you're using, and I will infer it for you. That's the general thing that I ended up solving for. The specifics for uh, overloads is that an overload becomes a collection of functions. A collection of functions is a tuple. The tuples are just a struct with numbered fields. And so I'll just infer which one you want out of a collection of tuples, out of the collection of functions in a tuple. When you say
Hmm.
A plus B, I'll just infer which one you want. That inference then was like this giant overkill hammer, but it would solve for a bunch of other things that were kind of fun and cool I could do with that. But it would definitely solve the operator overload solution, which
When you
turns
say
into
it
function
reduces
overload.
down, when you say it reduces down to something like a type class check, like is this all are these implicitly constructed type classes where things can like implicitly implement them? 'Cause I think that's sort of like one of the things I worry about. I've been sort of playing with the idea maybe I should try to implement this soon. Of like, maybe I should try to speculatively implement operator overloading and just see what happens. But I think one of the problems is like, at least in my language, especially with generics or something, um, because my generics are templates, instantiating a whole function is necessary to figure out like the type of that function. And so if I have something that like has a pretty generic type, like let's say it's just a bare type variable, let's say I haven't learned anything about it yet,
Yeah,
then I call like, and then I don't know, let's say I want to like compare it against something else with like an equality operator.
right.
If that boils down to basically an overloaded call, then theoretically I have to like go through and look and say, oh, well, here's my big bag of all the overloads of equality that exist in my environment.
Right.
I'm this bare type variable. Theoretically, I could be any of them, right?
Right.
Uh, I have some capacity in my type checker to basically say, all right, I clearly don't know enough information, so I'll just come back later. But
I'm
either I think,
I'm doing Henley-Milner unification. And as long as I have a type variable that has goes into the quality guy, the first thing up is I don't know, and you get this big bag of choices. And then as the type variable gets more refinedly typed, I keep revisiting the bag of choices and throwing out losers until I get down to one or I get several and they're
okay.
ambiguous.
So then I think this is I think the approach that I would take, and I think that would work for most concretely typed versions. The thing that's been haunting me, and maybe this is actually less of an issue. I think this would maybe not be such a big problem for certain things, like maybe like equality, or like if you just want if you have some concrete type that exists and you just want to implement equality for it, you could basically you have some well typed, strongly typed, concrete overload that you could eventually whittle things down to. But the problem is like, well, what if you have multiple like generic forms? And so you have like,
Yeah,
I have a bunch of different overloads that are like
yeah.
different generic types, or like, God forbid, maybe they just specify that the type
I
has
have
to
a
implement some
solution.
type class, right?
I have a solution that you could argue you don't like.
Oh,
So
I mean, I'm curious to hear it. I want to hear anything.
yeah,
Like,
okay. So the solution is the the type inferencing throws out losers but keeps all the ambiguous choices indefinitely
uh-huh.
until it settles down. And that means that at some point there is a driving function, some particular overload resolution, some particular knowledge choice is only can be made one way. I don't end up with this scenario where I have this, I have a fact. I give this example here. I'll pull this fucking example out of hi yi yi yi. Let's pull up the doc. Like factorial with floats and ints. So somebody comes along here and writes this factorial function AA. fact is a function which takes an x, and if x is less than 1, returns a 1, otherwise returns an x times a fact of x minus 1. And for me, the 1 is a equivalently to an integer or a float either way. And so I could call fact of 3, and this will report as a 6. And I could call fact of 3.1, which reports to, well, it's 3.1 times 2.1 times 1.1 times 0.1. And that types, including the multiplies and the subtract for 1, the less than, all of those type as generic overloads. And then if you left it that way, I would type it that way, and you would get the version which has to do the lookup at runtime, the total hard lookup, and then I assume specialization. As soon as I make a specialization on any one of those arguments, the entire class, the whole function would immediately solve down to I'm an integer only fact that's all integer multiplies, or I'm a float only. Or I could do the same thing with strings. If I had a multiply on strings, it did something stupid. I don't know what strings would be, whatever you
Yeah,
define it, multiply and less than on strings. So you could
you
certainly,
eventually figure out I have this concrete parameter and there's only one thing that works. And,
yeah.
like it sounds like you're describing you basically do go through the function body every time. Or do you infer like a list of constraints like from the body
No,
initially?
I'm doing Hindley-Milner. This function body has it's only visited once technically to get me a type. The type is very generic. I can refine the type. If you don't make a call to some concrete thing, you have just the one body. If you make a call, like fact, polymorphism says, I take the fact guy, I clone the type, which is this very generic type. And this is standard Hindley-Milner. And then I apply a 3 to it, which immediately folds the 3 less than 1 to being an integer less than integer call, and the multiply, everything just collapses
Sure,
up in
sure.
an integer only solution.
So yeah, yeah. So you're inferring like some set of constraints, and then like that set of constraints is essentially then kind of like a function. You then plug in like a type in and say like, yeah, if I pass in an int, then that proves that my function
So
is int to int or something like that.
just to be
Um,
clear, I get a very generic type up here, but the generic type has the less than and the multiply and the minus are all operators. They're all turned into function overloads. And I do
mhm.
an overloaded function lookup for each one of them in the type system. And then I left with this very generic fact. And then when I hit one of these integer guys, this standard in the Milner, you clone the type, which is this very generic type, and you get it. So I'm trying to think of it as a better way. I haven't done this in a while, so it's a better way to do this. Here, this turns into the less than operator. That didn't help Google. How do I keep Google from attacking me?
Oh, that's funny that they do that by default.
Yeah, right. And this
That's
is
incredible.
still a 1 because that's generic already. And
Yeah,
this
yeah,
is the multiply. Or maybe I can do, you can only do this? No, I have to do this. He's okay. He's getting confused. Comma, fact of, sub of x, comma, 1.
yeah, yeah.
How are you close parents? Okay, so
And then you
stop.
sort of get out some type that's like, but the type of this function is I need something for which, mul and less than and sub and fact are all
Right.
implemented,
So less
right?
than comes through and he says, well, I have version 1 here. I have the int flavor, which is a function from int to int arrow int. And I have a float version of float and float arrow float, but I also have the version that's int and float arrow float and the corresponding one for the other direction. So I don't name these fields; they're just in a tuple, so I don't need a name. So you get a tuple out of it. So I'm writing it with named fields, but instead I could just do a tuple. I would do a tuple and then just have a collection here
Sure, sure.
this, like this. Anyhow, the type guy does he says I have to pick one of these. So buried up in here in the syntax for calling less than, it's really load a field. I'm going to use a dot underscore where, oh, come on, Google, how do I make him not do that? I need an underscore here. underscore less than, let's see. Oh God, he's just completely confused now. I don't know how to get rid of the formatting.
I mean, it's okay. I think I go like I think I understand what you're saying in broad strokes. Like
There's
you know,
a dot underscore as a field whose name is not known. And
yeah.
that's the one I infer. This field lookup, that's an unknown field name. I will infer which of field zero, here's field
Hmm.
zero, and here's field three. I'll infer which field you meant. That makes that type work. And as soon as X becomes int or float, I'm nailed down to one of the pairs, two of the four pairs. And as soon as the other side's known, I'm nailed down to the singleton type.
Hmm.
So
Um,
it's the thing that I've extended Henley Milner with is do this overload resolution, which he does by exploring what fails. So whenever the type for the type variable for less than changes, so I improve it from being an overload of these functions to an overload of some set of functions or some type variable that's matching against it changes X from unknown to int. I reapply the overload lookup. He throws out some loser choices, so his set of options the next go around keeps shrinking. And when he gets down to one, he just replaces the one in and
okay.
moves on.
So okay. I mean, so you are essentially reapplying the constraints repeatedly. Like the thing that I think the thing I want to just be clear on. Let's say you had some like I don't know. Oh my God, the
We can make it,
capitalization.
yeah, we can make a smaller, simpler example than factorial.
Well, I think factorial is fine, but I think my one remaining question is basically if we have like some x, and let's just say it's like unknown. Like say we're in a situation where we don't know anything about this,
Yeah,
you know, variable yet,
right,
and then we call fact of x.
right.
Do we essentially infer like x is some like such that, like
You have X, yeah, we do
like all the
infer
constraints of fact, like
the constraints it needs that X has to support a less than operator, a multiply
yeah, yeah.
operator, and a subtract operator,
And so you take
subtractable
whatever
operator.
bag of constraints you got from type checking
Yeah,
fact, and then you
yeah,
just add that in here, and you're like, yeah. So make
yeah.
sure that X maintains that.
And
I think
and
that makes sense.
that standard Hindley-Milner, that is the unification of this scenario is that X unifies against the arguments requirements on fact, which are already known. And the unification is this one clock cycle thing. You just standard union find.
I think you are starting to convince me. Like, I think so. So historically, I've kind of pushed back on these sorts of things, like mostly just the idea of constructing these tuples, right? And I understand these are compile time tuples, but I think,
Yeah.
my main objection before is like even just constructing this, right? To type check this function is like I have to allocate like a whole bunch of function types, and I have to allocate a tuple that contains all of them, and just the like burden on the compiler is like a little expensive.
It,
Like it uses some memory. It's not a crazy amount, but my
it,
compiler is quite fast, and I want to maintain that.
right, I don't know how well Hindley Milner goes to the large scale with all the extra things I'm piling in on here.
Which
I
like
made
I mean, my guess is I think it's probably still fast enough. Like this isn't like a super difficult thing to do, right? But it's
right,
like
right.
I generally just try to like really pare down stuff so it's like really efficient in my type system. Like
Same
most
boat,
things are
same
only
boat.
like
Yeah, yeah. Simple has some thickness to it in order to be tutorial-like, but I generally chop things down as fine-grained as possible. Here, I
that
kept
all
adding
said,
things back in order to add features to the language where you could just overload an operator, then use it in a natural way without having
yeah.
to screw with the types forever or get super specialized or whatever. And that kind of chomped on me a bit, but the typing wise, it worked out.
I think that all said, like I think you are convincing me that this is probably a good approach. Like I don't think this would be difficult to embed in my system. Like I still basically have Hindley Milner. I just avoid building up complex constraints like this.
Hmm.
Um, but it wouldn't be super difficult to add a complex constraint. And probably like my alternative was like, I mean, in the case that we have several concrete overloads, I think I can currently handle that pretty much fine. Like at a certain point, it is clear, through sort of a different mechanism, like,
Well, for
like
me, the
at,
different mechanism here is these will give you the correct types. That is, fact of three will report as an int result, and fact of 3.1 will report a float result. But your generic executable code for fact still has to do this dispatch at runtime. And that's a red flag that says, oh, make inline once, specialize, and now you get a fact of ints and a fact of floats and a fact of
yeah.
strings. Yeah.
I mean, I think the runtime dispatch versus like templates is, I think, that is, I think there are some differences inherent in that, but it's relatively it's a little bit more secondary. Whereas like I think the big thing is mostly like uh you know basically just doing this dispatch, right? At some point checking and revisiting and saying, have I figured out which overload I am yet?
Right.
And you do this structurally by constructing like, hey, here's my actual tuple with all of my overloads.
Right.
Continue to check this. Whereas I do this sort of more by like scheduling, where I basically just say periodically in some work list, like revisit this
Oh, no, I'm
X, which
doing
has some
this.
variable.
I am doing the Hindley Milner on a work list.
Or I guess so the difference that I do is mostly like, work list notwithstanding, is mostly that I just eventually say like I run some code instead of querying some type that is structurally encoding all the overloads. I just have some function that's like directly query my scope and like go dig up all my overloads from, the scope
Okay.
graph or something like that,
Yeah.
which is, it's not a super significant difference. Um, or, I mean, same endpoint, I would imagine. The big thing I was worried about is I think essentially like imagine you have this, but like half of these are like generic, right? Like let's say that, instead of having like some less than, it's like, int and
Well,
float or all these concrete things.
I have
Like
three in here, right? This short little guy has a multiply, a subtract, and a less than. And in general, any large expression, you'll have a bunch of things, and you're carrying a generic through. Every one of them will have a generic add-on.
what I mean is like let's imagine like for one of these, like, like for one specific function, like less than, like what if there's an overload that's like, it just takes some x and y and it's like where I don't know, like foo x and y, like some arbitrary like type class. Like let's say we just have some trait and we want to define some super super generic overload of less than for two arbitrary things such that this trait exists between them. This is where it gets kind of like tricky. I mean, maybe not that tricky, depending on your type system. And probably your like structural approach is really the only good solution here, because like, in your case, you would basically encode this as like, I don't know, you could basically figure out some, function
I
type.
would I would end up
Um,
with versions of things that had a for me, all the things that look like interfaces, I turn into uh, fields in a struct or a tuple that have to exist in order to be declared a member of the interface. So it's just syntax. Basically, I turn it into syntactic sugar. Anything you
mhm.
do with an interface, I'm going to do with syntactic sugar. I'm going to add a hidden magic mystery field. And if you are structurally equivalent, then you just work. If there was no interface involved and you're structurally equivalent, you work, which is what we're looking at. But if you want to say also you have to be a member of this interface, then I throw a magic hidden field that's called secret foo. And if you don't have the secret foo field, you're not that interface. And that's just structural
Mhm.
equivalence. That just I do the structural equivalence with a syntactic sugar bonus field.
Where that secret field is basically like what, like some,
It's
abstract
some
symbol
it's
saying like, here's an interface that I have.
the secret field is literally got a name that no one else has unless they were
Mhm.
declared by the parser of that interface type.
I see. Yeah, yeah. So that makes a lot of sense, and that would be easier. I currently have it, or I want to maintain basically implicit interface implementation. So just, if so in my language, if you have something like this, the way I want it to work is, if you were to call this on two variables, uh, neither of them should have to have been declared as having some particular type class, or there should not necessarily be like an instance of that type class. But, we then have to do this query of like, well, actually, do I implement foo between these two types at some point? Um, and then the other kind of problem is that because I have this instantiation based generic system, that could theoretically lead to like this big code explosion. And so I think that's like, a lot of my consternation. But I think honestly, like this like the idea of doing this sort of structural constraint is probably not too like that still might be fine, because I think like the thing I'm realizing is
Oh,
that,
geez.
these types of template instantiations are only an issue if you have like multiple possible generic overloads. Like the worry would be you have some sort of branching path, right? Where it's like there are three generic functions that could potentially match my arguments, and I don't actually know if those arguments satisfy. Like I actually don't know yet in my type inference which type classes they satisfy. So I guess I'll just instantiate all of them. Like that would be the nightmare scenario, because then you could get some sort of horrible exponential code explosion. Um, but you know, thinking back, like if these are just overloads, then if you have multiple generic overloads of something, like it would really be wrong to speculatively instantiate all of them. I think it's probably reasonable to wait until you can unambiguously pick one. And if you get to a certain point where you've learned everything you can and it's still ambiguous, like that
Yeah,
probably should just be an error.
that's what I'm
So
doing. I wait until I keep going on the work list until it runs empty. If at that time I still have things not sorted out, you get an ambiguity error. If anyone sorts out in the middle while I'm running along, okay, that guy's nailed down. He generally implies the next guy's nailed down, and suddenly you
mhm.
all resolve.
Yeah, yeah. So maybe that should actually apply mostly fine to my language. I was worried about like the thing that spooks me is like if I have something like I don't know, fun less than, or let's just make this, let's not make it a literal less than operator, but we have some mystery or something, and we have like just some arbitrary function like this, right? Like it is valid in my language for this function to basically take something where we know nothing else about it, and for us to have to fully expand this template style to discover that, oh, actually X and Y are like plugged into this comparison against an integer. Um, and so like, there are a lot of situations in my language where we might do like some sort of overload resolution, and these are like bare type variables, and we just pass them in and we instantiate this whole function on like completely bare type variables to figure out their constraints. Um, but it's probably a reasonable requirement to just to say like don't do that if there's any overload ambiguity. And so then probably that's just a reasonable like weakening of the language. Anyway, these are my like subjective, I guess, language design quandaries a little bit, but
So, so this is where I'm talking about with the interfaces. Um, Here
mhm.
I have a function distance that just takes a point, pulls an X and a Y field out, does something with them, squares and adds,
Yeah,
whatever.
yeah,
It's typed as a function, that's the open brace. It takes an anonymous struct who has an X field and a Y field, and it returns me an int.
yeah.
If I declare a point, well, that struct has an X and a Y. Oops, let's see, close. Has an X and a Y, and that's good enough. Or if I write an anonymous struct literal, that works.
Mhm.
Or I can have a distance which takes a point object specifically, and that takes as an input a point thing, which is implicitly has this magic extra field. Now, I'm
I
going to
see.
write you syntactic sugar for how I describe the points as you're a point struct, but in
Yeah,
the
yeah, yeah.
land of oh, come on, stop that, Google.
So it's like a structural type, but it has a brand to
Yeah, it
say
has it.
this is my
Yes, yes.
specific.
A brand is a
Yeah.
good name for it, right? So this guy gets rejected because
Mhm.
he lacks the brand.
Yeah, yeah. I mean, I think that all makes sense. Like that's a good way to do it. These kinds of structural type systems, I think, are really cool. I've mostly just kind
Yes.
of like not done it. I don't know. When I was designing my language, I was in a very nominal typing mood. But
Well,
yeah, like this
I
this
can
this embedding
incrementally
of like,
I can
you
do
know,
nominal and structural typing back and forth on a case by case basis,
oh yeah, yeah.
struct line
Like
by line basis.
I mean, this is how you embed nominality in a structural type system.
Yeah,
And I think,
exactly.
it's
Exactly.
to some extent, I think it's like a real boon for structural typing, and that like structural typing is kind of in some ways strictly more powerful because you can
Yeah.
express the like more specific nominal type system just naturally as part of it.
Yeah.
Um,
So from here, I can get to things that people call generics by just using more of the same game.
yeah, yeah. I mean, it's you have some it's all constraints, right? And so you have
Yeah.
like a constraint of like, theoretically, I just want to be open to anything that has these two fields. And,
Yeah.
then it becomes an implementation decision of do I do a runtime dispatch or do I, specialize this, or when exactly do I specialize this? But,
Yeah.
on a
I'm
type system
usually
level, it's still
against the
this,
best in chat.
Somebody's talking.
Sorry.
It's okay. And Ben has good stuff in the chat I wanted to bring up too.
oh
I was
yeah,
going to
sorry,
say,
I have
I'm
not
usually
checked chat in a
against the
while.
best.
Okay. So I'm going to go over chat, but somebody else is talking who I can't see because I have the other window open. And he's saying global decals need to be stored globally and accessed for any part of the compilation process. And here, and then he says interning or memoization is the savior. Yeah, for me, I am not needing these as global decals. If I were
Of
to
course you do.
write,
If you're in some part of the program, you need to be able to find out what's previously been declared. You have to store it globally.
okay,
It's
I have
memory. It's
the
like the non-lexical stokes.
yeah, I have the implementation. I have an AAA that is 3/4 done and not complete. Says things that are declared at any given scope level of certain kinds of things, including type definitions like this. I'm willing to reorder under the hood in order to make them all match. Or to make them, you're right, I make them global within a scope, but the scope could be top level and be global. There's just some scope. You say point P, and if instead down here if you did these in the wrong order, so I'll just put this down here in the wrong order and claim that you are correct. I wasn't thinking about it. It is in fact going to be global in the sense that I will take these two decals and sort them according to topological usage and declare no, this is not an unknown value. That is not an unknown type. Although I will make it AA friendly types with a colon in the type.
Well, it will be unknown, but then it goes on the work list, and later it gets
right. Somebody says I don't know what this type. Right, exactly.
Yeah. It'll start
Or
as forward.
you actually put like
find the concrete reference.
Yeah, and I'll find the concrete reference for it, and it'll unify up and be all good. Yep.
Unless you try to call it while it's still a forward reference. In which
no, you don't call
starting type inference.
I'm missing something. During type inference, it starts out life as a type variable known to be a struct type with an X and a Y field pretty shortly, but it starts even just at the very first point as it's an open-ended struct. It's an open-ended type variable. That's not fair. It's an open-ended type variable, rapidly becomes an open-ended struct with an X and a Y, and I don't know what else. Suddenly I discover the thing here, and I do it this way. P is a variable, which is a type variable, so it has a leading colon, and that turns into a point as a convenient name or an X and a Y. That's the AA syntax for it, but whatever done here. Then when I find the point, I'll say, you're close. You only have an X and a Y, and you don't have anything else. It's all good.
And I guess there is kind of the important point to be made that while there is like scoping involved in the language overall, like you wouldn't really need a scope for these individual types, right? Like, like really like one of these types is just a bag of fields. It could be a list of strings or something like that, or, maybe more complicated.
Within a struct,
but it's kind of independent of scope.
In a struct, they are unordered. X and Y are just in the struct declaration, but they're not.
Yeah.
No order to them. Yeah.
So how do the type shadowing rules work? Because isn't it going to have the same kind of problems as the variable name shadowing?
It does. And so my theory on that one is you're writing a type error. So I'm going to slap you around. If you're within the same scope and you redefine point several times, I'm going to hit you with a hammer and say no. Strictly because I think you're stomping your feet. If you nest and put a new scope, you can override an outer scope type.
At the risk of sounding like one of the Lisp 1, Lisp 2, can I have the same names for types as I have for variables? Or because it looks like from the syntax you can distinguish types and variables, and I don't know if it's a best practice to say no, these should all go into one bag and never be identical, or maybe actually it's fine to have.
They go into two different bags because this is a colon type. Sorry, this is an assignment to a colon, so that's a type assignment. This is a value assignment. They go into two different bags, but you could have another point assignment, and
so I could totally have a class point and a type. I could have a struct point and a type point in the same program.
I keep correcting my syntax. This is what I was trying to get. Okay, so say yourself again here. I have a point.
I feel like I could have both point equals this type and capital P point equals 5 in the same scope.
I think I'm
very confusing, and I don't know if it's worth disallowing it.
I think I could be. I should probably disallow it as you're going to cause trouble. I think semantically I can tell them apart because you're not on the right-hand side of a colon. The 5 point is never showing up on the right-hand side of a colon. That's a namespace change. I said point PT colon. The colon there says I'm starting a type. I'm looking in the type space. I found a variable. I look in the type namespace. Oh, I found a point which maps to some type variable that does whatever, and on we go.
So if you want to disallow that, you're going to have to write extra code to disallow that.
I have to write extra code, and I might have that extra code now, and I might not. I don't remember where it's at.
Do you have anything where like I don't know if you have like function style constructors or something, but if you were to then do like, I don't know, x equals point of 42 or something like that,
Oh,
is
that's
this
what okay. So Aaron's correct. I don't allow it. You just hit it, and exactly when you do a type declaration, you get the type for point is on the what you get on the right hand side of the point, and on the left hand side you get secretly a default constructor that takes an x and a y and produces the x comma y comma magical point field guy. You get a default constructor. So calling point immediately gets you a constructor. This one complains you didn't put two arguments in, so I'll put a second argument in for you, and you get a default constructor. So you do get two. You get the other side shadowed as well. So one declaration of a type gets you the value version in a name in the value space that is the constructor.
So let's say we have point only ever appear on the right-hand side.
Yeah.
But you can infer a bunch of properties about it from the way it's used.
Yeah, you will get told you're missing point. You have an undeclared thing.
Okay, so Henry Miller won't build a constructor for me because there was no ambiguity.
He will go up until, because you haven't to get a declaration, he only knows that point has fields x and y and more yet to be defined.
As well as potentially ambiguous order.
I'm sorry? It's within at the point in time that if you close the scope and point never escapes any possible point of escaping, there's a theory that says I could come through and say whatever point had to be, it could only have an x and y. It may have an infinite number of unearthed fields that no one will ever look at, so I don't need to implement them. So I could invent a point structure that has just x and y and walk away.
Yeah, that was my question.
That's not what I'm doing. I am going to walk to the end and say, you should have told me that point has only x and y, or maybe it has x, y, and z, but you're not happen to using the z, but you got to tell me.
But only if I want to use the constructor. If I don't use the constructor, it's
no,
just
then instead, yeah.
consistent.
Right. So in a new program, I write this, but you don't declare point. You don't call dist because you don't have a point object. You can't call dist. If you said this, I'm making a point of 2, 3. He's going to come to you and say, you didn't declare point. And instead, if you don't declare dist, then you don't have to declare point, and it's all just dead code, and he doesn't care.
What stops me from just putting in an anonymous struct that dist is going to recognize is a point?
Say that again?
What stops me from putting in an anonymous struct that has the same shape as point when I call dist?
You can put in, yeah. That's the bonus extra field that you got when the type got declared. So you can't call dist with in this declaration, you can't call dist with an anonymous field which has an x and a y that are declared usefully, whatever. This would be a thing you would otherwise be able to do, except that's not a point. And I don't know what a point is, but it's not a point because you don't have the magic $point field. So I would say no, you lose.
Because it's nominal typing.
Because it's nominal typing. Because you said colon point, you got a name, so you got nominal typing. So now you have another one. She had two types. Okay, so first one, X. The second one would blow up and say, oh, you're redefining a final field. You can't write the second point in scope. That's a reassignment of a final field. Right?
What if I add one more colon, so it's not a final field?
No, it's equals. That's a final field assignment.
That's right, but if you make it colon equals, won't it not be a final field assignment anymore?
I'll blow up on you and say you can't redefine types.
Okay.
You're saying, yes,
all types
I have a mutable field right. I'm going to mutably...
All sales final, do not redefine your types.
Yeah, don't redefine types. Yeah. So the answer is no, it does not work. Maybe I could make it work. I think you would be asking for trouble if you tried to write this kind of code. Like you'd be like, what the hell am I doing? The future reader would come along and be like, what the hell is this? All right.
I think a lot of these scoping quandaries are like theoretically, there's a lot you can do in terms of telling different namespaces apart and like only certain cases where they're ambiguous. But I think my general take is like it is almost never a good idea to allow like having the same name exist in two places. I mean, like,
Yeah.
even shadowing is kind of questionable. Like there's a bunch of places where I've noticed like Java just forbids you to shadow, even in places where it's like super unambiguous, just because they're like, yeah, we don't want that business.
I think it depends on how powerful your stack system is and what do you mean by the same name. Because for this code example, I see a very clear application when you want to have a point to mean 2-dimensional point, 3-dimensional point, or 768-dimensional point. I still want the type to be called point because it is a point. It just happens to have a different dimension. But of course, you can make the dimension another parameter of the point, like some kind of point n.
Yeah,
I would demand you had the dimension as an extra parameter. Yeah,
I think a case like that, I think it doesn't really count quite as much because I would mostly just say that that's less that you have multiple definitions of point and more you have like a single like generic type or type factory or something called point that
Exactly.
takes a parameter, right?
Kind of like close in my head to parametricity, right? Because it's like we are not allowing ad hoc definitions of point to be like completely different for n equal 2 and n equal 3, but we have like a whole parametric family, and n is just a parameter, but it's fundamentally the same type.
I can give you, through inheritance, I can give you a generic point and then a 2D flavor and a 3D and an ND flavor. But the ND flavor won't inline a constant n by default. It would be special extra inferencing would have to happen there. But like there's a generic point that has no fields, and I don't know what the hell you call it. And then, oh, I got nothing. And then there's a 2D, which is a point, which adds an X and Y. And then there's a 3D, which is a 2D with a Z, right? Whoops, 2D, and he just adds a Z. So I just keep adding fields that way, but I'm getting unique type names on the left and then making a tower for points. That's not what you're looking for for the ND. The ND requires a different implementation. It has to have an N and an array of values.
Or I mean, you you could have something like I don't know, using kind of like
you could also
Haskell-ish syntax, right?
Usually, if you do an interface, you want to have something the interface requires you to implement.
Like this would be, like we have one type, or like maybe dubiously a type point that takes some number, and then
right.
And I guess this wouldn't work because we need like some base case, right? But like, let's pretend we have like a type ternary operator, something like that. I don't know.
Don't ever make point 2D extend 3D. Okay, nice, man. Okay.
Yeah. But in a case like this, I think from a scoping level, I would mostly just consider this as like point is something like int arrow type or whatever magic thing that I have that's equivalent to that. Like in my compiler, I call it like quote unquote generic type because it just it has parameters.
And here I've kind of hit the end of my. I know I really understand what's going on. I know exactly how to implement level of typing. So I can screw around here, and I would have to explore before I believed I could do an implementation that I liked, was Hindley Milner-ish, was fast and efficient and cheap, and had a most common type or whatever the most unified type kind of thing. There's all the nice little properties you want.
Carbon language had an interesting talk on implementing this. I can recommend that actually.
I would have a what implementing it?
Carbon language. There was an interesting talk on implementing this kind of things because they want to have something close to templates, but actually checked. So instead, like in C++, you don't, before concepts especially, you didn't have any type checking. And it turns out this is a little bit non-trivial to do when you want to have variadic templates. So exactly like point n. But they actually did get this work, and the algorithm was fairly simple in this talk. You can just YouTube it if you look for Carbon implementation generics. It's probably like gonna be like first result. So I'm not gonna even bother looking for the link. It's very easy to find.
Okay. Something about.
Do you know off the top of your head, is it something like, if you have your like, let's say we've got our
the link together here. I'm editing a sign time somebody else here. I don't want to stomp. Sorry, go ahead. But I want to wind it down here.
Oh, sure.
So
I was just
last
a
hour.
quick question for Matt was basically, if you have some variadic template like this, do they basically, and let's just, there's some body, do they impose something like, args has to be like all members of some concept, like where it's like, I don't know, like let's say this is like a print function and we've got like, like well, like, is the main requirement? I mean, I'm mostly just trying to get a sense of like, if you say that like they want templates, but they're checked. If you have a variadic template, does it check that they like all satisfy a certain thing? Does it check that they satisfy like a list of things? Is it like, you know? Yeah, I mean, I can probably go look up the talk, but
sorry, I was looking for those things actually, and I just posted them in the chat. So there's the two parts
oh,
of
okay.
the
There's something in the chat.
definition check the generic part 1, definition check the generic part 2, and the GitHub, and someone already has posted GitHub, so I guess that's close enough.
Oh,
But
I guess
start to be good.
Yeah, sorry. If you mean checked templates as in like they're like parametric, right? Then like, yeah, okay, I see how that's hard. I mean, it's not crazy, I guess, but it's like, you'd probably need some like row polymorphism or something for the var
Yeah,
But
args.
they solve more, they kind of have a consistency checking that is fairly simple, I would say. It's a pretty even elegant idea.
Mhm.
I would point to the exact slide example, but this slide takes a while to get through. So
I can check it out, or I'm sure we can all check it out after the meeting.
okay. I'm going to
It might
call
be
quits
interesting.
here because I have things I need to do. And we're after hours. So this has been very exciting, and I'm happy to start this up again tomorrow if we want to talk variadic, or next week, variadic types again. It's all good. But I want to be done. Yeah, I'll leave the document editable for a while if people want to screw around. But then, yeah, great fun talking to people, and talk to people next week. Bye-bye. And go to sleep, Theodore, in your bed, not on the camera.
have a good weekend.
Right.